Let's look at another example of compound events. In this case, we have organized our data in a table to help us look at the various outcomes of each event. Let's start by totaling each event. So in the first column, here we have the people that died of cancer. We have 100 smokers, 100 non-smokers that died of cancer. So summing up just that first column, we have 200 people that died of cancer. In the second column, we have 180 plus 120 will be 300 people that died of heart disease. And then for other causes, 120 plus 380 will give us a total of 500 who died of other causes. Now let's add up the rows. So looking at the smokers in the first row, 100 plus 180 plus 120 will give me 400 smokers. In the second row, we've got non-smokers. Summing those up, we've got 100 plus 120 plus 380 will sum to 600 non-smokers. So notice that in both the rows and the columns here, if I total them all up, there should be 1,000 all together, which agrees with our study of 1,000 in total. Okay, so reading the first example, someone who died of cancer. We want to know what's the probability that somebody died of cancer. So what we can do is we can look at the total number of people that died of cancer. In this case, there was 200 out of the total number of people that were in the table, which was 1,000. So that probability would be 200 over 1,000. Someone who did not die of cancer, well, we see if we're not including the people that died of cancer, there would be 300 who died of heart disease and 500 that died of another cause. So summing those up, we have 800 over 1,000 who died of something other than cancer. Looking at someone who died of heart disease and cancer, well, since these are disjoint events, in other words, there are no people that died of both cancer and heart disease according to the table, we would assign a probability of 0 to that event. Someone who died of heart disease or cancer, well, we can look at now the sum of those two probabilities. And there's no intersection of those two. So that would be all the people that died of heart disease or cancer divided by 1,000. So 500 over 1,000. And then finally, someone who smoked or died of heart disease. Well, now we can look at our addition rule here. Someone who smoked or died of heart disease. Well, we can use our addition rule. So we have the probability that somebody smoked. Here, I'll just give that an S. Plus the probability that somebody died of heart disease. Denote that event with an H. Minus the probability that someone both smoked and died of heart disease. So we see the total number of people that were smokers was 400. The total number of people that died of heart disease was 300. Oops, sorry, an extra 0 there. Ignore that extra 0. Minus the probability that somebody was both a smoker and died of heart disease. So that would be these people here. There's 180 that were both a smoker and died of heart disease. So then combining 400 plus 300 minus 180, I believe leaves us with 520 over 1,000.